Hello everyone. This video is the second part of the video we made for bending actives, so part 21, because there were a lot of requests that how we can make a grid and then we can make it from 2D to 3D. So in this video we will elaborate on that. So building on what we had in part 21, if here we want to have for example two elements, because in that one we only had one element, one curve, here we can see what is the difference. So let's say we have two curves inside our Rhino screen. Let's say their lengths will be something like 10. So we have these two curves. So here I will bring these two curves. And then I can hide them inside my Rhino screen because I have brought them inside my Grasshopper. And what we need to do is the similar process. So we divide these curves into, for example, 10 or 20 pieces. And then we need to make a polyline out of it and use a Kangaroo for making it as a rod. So what we do, we start with dividing the curve, and I'm using one slider for both of these two curves, for example, to start from 10 and have a limitation of 30 at the maximum, using this number slider. And what I need to do is to make, as we said, polyline. So we have two polylines for each of these two set of points, and then we need to set up our Kangaroo, which means we have the solver, we have set up the goals, for example the load, the anchor to say which point to be fixed in the space and which point to move on our screen, and other goals, for example, to keep the length of the curve as it was, and the most important one is the goal rod here. And also we need to use the show to see what is the result. So I'm using these two polylines as what I want to see the result of. And let's also make some space here. This set of points, I will use them as the loads, so the location where load will be added to. And it's automatically on Z, but I can also set what is the weight. Maybe it's too much, so I will change from 0 to 1. Then we will check how it affects. And the polyline, the rod should also be connected to this polyline, so I will connect it also here. And the lengths I will also connect to here. And about the anchors, so I want 1 point from this polyline for both of them to be kept in its place, and the other 2 points to move toward it. So how I can do it is to use a list item from this set of points that we have. So here I will have one list item, so taking the first point and reversing the list to get the last point. So this point and this point. And also for the second list, we also do the same. So copying this part, connecting this time to the second list of the points. Maybe it's even easier to bring them here because we want to do some changes. So this point, we want to keep it in its place. So the anchor will be only this point, and we don't consider a target because it will be kept in its place. And then for the second point, which is this end point, we will connect it here. So this is the initial location, and we will move it toward this point. So I'm going to use a vector to point and select this point as the start point, and the end point will be toward the starting point. And now I'm using a move, and if I connect it here, the location will be exactly there, but I want to move it. So instead of directly connecting it here, I'm going to use a multiplication and connect it to this vector to say from 0 to 1, so using a number slider, and then you can see that it can move toward this point. So this will be my target, and I will keep it for now on 0, so it's in its first location. And I will do a copy from this part, the whole part actually, and use it for the second set of points as well. So meaning that this will be directly connected here, it will be kept in its place, and the second will be connected here, so this location to this one. Okay, now that we have everything set, we can use merge, or maybe even it's better to use entwine, because this is to keep the structure of our data, and I want to have the initial input as the two polylines and all others to the second input. So I keep shift to connect them all. And I don't need this extra one. Okay, so now I connect this to the goal objects. I need to also have a button here to reset, and also a boolean toggle to set that it's working or not, which I will use true. And the output, I can use now an explode tree, and I know that because of here the first input, so here the first output will be my polylines, so I can easily connect one curve here and only see the output. Okay, now let's see how it's working. So we can also use one number slider here, so this will be how we can move our endpoints. So let's see how it's working. Okay, so here the Z value of the load is 0. That's why it's just moving on the screen, so it's not coming up, which is not correct. So if we increase it, for example, to 0.01, you can see the effect. So coming back to 0, and now let's also hide everything here, and also here. I want to only see the output of these curves. So coming from flat into this shape. And now you see that it's not smooth, so it's not actually like one rod, elastic rod or flexible rod. To make it like that, we need to increase this number. For example, something like 20. Let's see how it's affecting. And this point here, you see that's exactly located and at its location. So it seems that these two curves are connected, but the reason is because of our initial curves, that they are exactly the same size. So let's say if I move it here, and also if I increase the size, so increasing the length in one direction, let's see how it's affecting. Coming back to the flat state, almost flat because this number exists. Let's also hide them again inside our Rhino screen. So now here you see that they are not connected. And how to solve it? It's an important aspect for us, because later if we want to have a grid, we also need to consider these connections in between. And how to do it? We need to do some changes here. How to consider it? We need to, let's hide it here, and we can disable it for now because we want to only work now on the starting part or the setup. So we have these points, the division points, but we need to also consider the intersection point as one point and then merge it with the points, set of the points that we have for the division, and then make a polyline out of it. So in this way, this point will be considered and then they will be connected together. So to do that, I will go to this intersection part and use this curve, or maybe easier will be to type curve x with the x with caps on, curve, and then I will use one curve as the A and the other as B. So I will get this intersection point here, and now I need to merge it with these points. So let's make some space here with keeping Alt, and then I will use merge, and this will be one point and this will be the other. And then we need to also repeat the same process for the second one. So copying it here, the first point is this one and this is the set of points. And then if we directly connect it here, it will make at least a polyline that starts from here, coming here, and then ends in this point, because the sort is not correct. So to solve this, we need to do sort. Also, it was better maybe to show you. So if I use a point list here, you can see what I mean by the incorrect, let's say, order of the points. It's too large. Let's use something like 0.5, and you can see here that this point is number 0, then it starts from 1 to 21. So the point will be that the polyline will be starting from here, coming here, and ending here. This is not what we want. Instead, what we want is to sort it. And we need to do sort align curve, because we want this curve to be used as the method that the points will be sorted on. So I'm using this merge, and I'm using the initial curve here as the sort. So now if I use this list here, you can see what I will get. So, oh, sorry, I did a mistake. This was used for the first one and this is for the second one. So here, you can see that it starts from 0, comes here, this will be number 10, and then it ends to 21. So this is the correct one. And we will use this list for the polyline and repeating the same for the second one as well. So meaning that this set of points will also be sorted, but with the second curve. Okay, so now let's bring them back, make it true. And now you can see that if I move it, and let's also hide it here, the points are connected here. So these two curves are connected at this intersection point. And this is how we consider that these two elements are connected at this point. Okay, so we saw here how we make it for two elements, and so I will also upload this code or this definition on Food for Rhino, so feel free if you want to review. And I will call it 2 curves, or actually 2 flexible curves connected at one point. Okay, so now I want to make a grid and then use the same method to make it from flat or 2D to 3D. So I will copy this part, bring it here, and this time I will also draw it on my Rhino screen with the size of 10 in one direction, and I will use array linear, make, let's say, 5 elements with a distance of 1 or 1.5, and I will also copy them, make a 90-degree rotation, and this will be my second set of points. So here let's also disable this part, bring it here. So here will be one grid, and we need to do some changes, so let's go through it together. So the set of points that we have for the start, I will use this as this first set of points, first set of curves, and then this will be my second set of curves. So now I can hide them inside my Rhino screen and show them inside my Grasshopper. So here let's see what we need to change. So we have these division points, that's correct. But here for the intersection, let's see if it's correctly considered. It is not. And the reason is because it's considering the crossing only, because considers each curve from the first category or from the first group to the first curve of the second category, and doing the same for the others. So the second curve from list 1 will be considered with the second curve of list 2. So to solve this, we need to graft everything from beginning, because we want each curve to be considered separately. And here it comes that we need to say that for each of the lists, we have the first one as the graft, and the second one we want to flatten it. So we have this, and here we get these 25 points, and we need to also do the same, but here in the second list we change the position of the A and B. So this will be A and this will be B. And then what we need to do is to see what is the structure that we have here. So we have 25 defined values, and as you see we have it from 0, 0. So this what we see, or let's also show them with a panel. So you will see that each of them are considered as separate branches. And let's see also here, is it similar? It's not. So you see that they're all considered as one branch. So to solve this, we need to do shift pass. And we have talked about this in our previous videos. You can just check if it's not clear for you what we are doing. And here we get, so if we compare it here with here, the structure is getting closer, but we need to also do simplify. So you see that here now I have 5 branches, and here I will do the same, and then it's easier to work with it like this. So I will make some space here, and I will use merge here. So this will be the first and this will be the second. So now we can see that for each of these curves, instead of the initial 21 points, now I've got 26 points, and I have used them based on each of the curves that they have and sorted it through. But there's a problem here. Let's see what's the problem. So it's considering some zero length segments, and the reason is because maybe the points, some of the points, the division points, are exactly located at the intersection, and this will consider that the length here for the segment of the polyline will be 0, and this is not acceptable. So to solve this, we need to do one thing after the merge. So let's again make some space here. And what we need to do here is to consider duplicate and remove them. So I will use this cell duplicates. You can also find it here. Cell duplicates in this tab for vectors. And I'm using it here. So you see that I have 130 points at the beginning, and then I will get 105. So I'm using this points instead, and everything will be fixed. So we need to repeat this also for the second set of the points. So here I will connect it to this intersection output, and then for the merge I will use this one as the D1, and the D2 is this division points as it was. And what else we need to do is using these duplicates and connect it here before the sorting. Okay, now it seems that everything should work, and let's see. So we need to also change something here. So we have the first set of points, the second set of points, here also, and where do we move them toward? Okay, let's see. We are moving them toward each other. Yeah, that also works. So let's see. I will hide everything here, also this part. And maybe we can also decrease this number, maybe to 0,001 to 1. So the number will be much less, and it seems more like flat. Okay, now if I increase this number, we can see that it's starting to bend. Okay. Let's see, we have 15 curves, and how many we had from beginning? So maybe we are missing something in between. We need to check. So here we have 5, here we have 10, so we did a mistake here. We didn't simplify it here. So it needs to be exactly as it was for the first list. I forgot to do this. And again, now let's come back, and the output will be 10. So it's important that the numbers are the same so that we didn't make any mistake in between. And here you can see that I'm starting to move these endpoints toward the initial points. And this was one method, but what we could also do is to consider one point at the center and then consider all these endpoints to be moved toward this point. And how we can do this is to consider that we don't have any fixed points and all of them will be moved toward the center. So I will get the center point, and that's by using an average of all these points that we had. So here, and I'm going to use flatten so that I will only get 1 point at the as the result. And what I need to do is to move these points toward this center. So I'm also using this vector 2 points, and here these points will be the initial points and this will be the target. And also copying this part of the move and the multiplication. So this will be the points. Okay, the objects to be moved, and the vector to move them toward is this vector, and I will also use this 0 to 1 so that I can move it toward it. So I can show you that, let's also disable this part. I want to only see how these points are moving, so you see that they are getting attracted to this point. Okay, so we need to repeat this for the others as well. So instead of this vector to point that we had, we need to change it. So this will be the B. And then everything is the same. So here also we need to repeat. So from these points to the same average point. And also here will be the same average point. And also copying this part. So this set of points will also be moved toward this vector, and this will be the target locations. Okay, so now let's see how it's working. So we move it toward the center and you see that we get this form. Okay, so as we increase this number, these curves will be more smooth. Let's say, for example, 30. Oh, it's too much, or maybe we need to reset first. And then repeat. And we need to also consider one thing. So here, if I connect a length and connect it here to all these curves, we knew that from beginning we considered a length of 10, but also we can see it here. Let's also flatten because everything is the same. And I will do also here, connecting a length, and we can check how it's affecting. So you see that the numbers are various, and this is not what we want, because we want finally to build this with a set of paper or plywood material, and we need to keep the length as it was from beginning. So meaning that these are flexible but not stretchable. So how to fix this is to, instead of using these polylines for the lengths, we can do explode and consider all these segments and keeping them as it was in the beginning. So let's see how different it will be now. Bringing it back to 0. And now increasing it. So it's not so much different, but a bit better. So now we can also increase this number. So it's now on 10, let's say 100. Overall, for all these goals, we can change these numbers if needed. By the way, since this number is so low, it's also considering to go toward the screen. But we can also use a floor to make sure that it's considering a floor behind it, and it will not go through the surface. So I will also use this here. And now let's see. Okay, so this time it's closer to the initial lengths, but again, you can increase this number and then check the results. For example, now 200. You see that the numbers are updating and the length will be kept more similar to what it was at the beginning. Yes. Okay, so that's it for today, and I hope you enjoyed it, and you can find the definition in the link below. Thank you.